Yeah, hi everyone. Am I audible? Hello, this is Bikram. Am I audible?
Yes, sir.
Okay, fine. So yeah, good evening everyone. So I am Atul Pratap Singh, and I am one of the instructor of this program. So today I'll conduct this Med 1 session, activity practice assignment session of week 7. So so if you have any doubt related to any quiz things, so you can ask later. Maybe others will join in very uh, maybe 15 and 20 minutes. So you can ask them. Before that, we will start the week 7 contents.
Okay, sir.
Yeah. Okay, so let's share my screen. Yes. So I hope you have watched the video of the week 7. So in week 7, basically what we are just learning the basic things of the backend system. What is our computer? So basic things of the computer architecture which we are going to use. So definitely, if we are developing an application, so in later time we will deploy our application in any system in any server. So we should know about the basic structure of our computer system, memory, and the database, everything, security. So all these things we are learning this in this week. So we are not going into a deep, but we will take just overview of all these things. So what are these things? So in the first, we are starting from the memory hierarchy. Okay, so everyone know the memory things. What is the memory? So basically, if we are working on our system, and definitely we are just creating a application, and we are writing a program. So definitely we need a memory. Okay, so memory. So in our computer system, so there are different types of label of the memory. So we will discuss the memory things. So before that, we will understand the computer architecture things. So how our computer works and where is memory things is uh, exist in our computer system. Okay, so types. So first thing, types of the storage elements. So I'm just drawing the computer architecture diagram. So what our system, how our system works. Okay, what's it? Pen is not working.
Sir, the 8 o'clock session you're taking, PDSA?
PDS session Bhaskar will take today.
Okay.
Just give me a minute. Something problem in the connection of Pente. Okay. Yeah, give me a minute. I don't know what happened today. Yeah, so in our computer system, basically, we have one CPU. So everyone know this. What is the full form of CPU? Central Processing Unit. Okay, so we can draw the CPU. So like in that way, and this is the one unit input. Okay, and there is one unit output. There is one unit for memory, and this is a CPU base. Okay, so CPU contains several things. So one is control unit, and one is register, and cache, and ALU. Okay, so this is the basic structure, and this memory also contain a primary memory, or we can say that the internal memory, primary, and this is a secondary. So this is the memory unit. Okay, and everyone is connected to the CPU. So in that way, so this is the basic architecture of our computer system. So here we are giving this. So from the left side, you can see that we can just give the inputs to our CPU, and after getting the input from the input anything, so it can take input from any. So it can take from our keyboard, mouse, anything. So after getting the input, it execute the our instructions. So basically, if we are running any application in our computer system, so it collect the all programs or all the instruction from the our primary memory, and control unit basically control all these things. So how we can perform all the operations, and this ALU is stand for arithmetic logical unit. Okay, so this is the basic unit that perform the all operation on the binary numbers. Okay, but so these binary numbers basically where we can store. So we store these binary number in our registers. So for example, if we are performing any program, we are performing any Python program. So basically, we are written this Python program in high level language. After that, we will so our compiler will convert into a machine level language. So we can say that, and that machine level language can be executed by our processor. Okay, so this instruction basically stored in our primary memory, generally called the RAM, random access memory, and this processor takes all the instruction from our memory, and it collects the data from our memory, and then perform the operation which is required for our operation. Okay, so it can be arithmetic operation, it can be logical operation, so it can be shifting operation, anything. So that all operation perform on the binary data. So because our system are working on the only on the machine, so our machine actually works on the binary data. So these binary things are stored in the registers. Okay, so for example, if we are performing any sum operation, okay, so 2 plus 3, like this operation we are performing, so this 2 is converted into a binary form, 3 will be converted into a binary form, then it will be passes to our CPU, and then our so these registers basically contain a data in on the temporary basis. So for example, if we are summing 3 value, so 2 plus 3 plus 4. Okay, so we will just perform the add operation on 2 value. Then we will store the result of this sum of 2 value then in our temporary register. And then we will perform the sum with the 5 plus 4 is 9, like that. Okay, so this is the main part of the CPU register that will store the temporary data. Okay, and this is the one memory which is the closest to the CPU. Okay, so this is called as a on chip registers here. So we can define the level of our memory which are closer to our processor. So first thing, this is a register which are most closer to our processor ALU. So this is called the this is called the register, and this is a very costly, and the speed of this memory is very fast compared to all remaining memory. So here you can see that this speed is given sorry, on chip register, so 10 second to so of bytes. So I think this is okay. So type of storage element, next is okay. So here, yeah, this is the size actually. So actually this register contain very small amount of data, or that it contains only a temporary data which are executing by the ALU. So the size capacity is very less for these register, and the cost wise this is a very costly. If we consider the cost for per for, according to the storage area. So for example, if we are calculating the cost per bytes or per bits, so it this registers are very costly. Second is a SRAM. What is means SRAM? This is generally we called as cache. Okay, so if you can see in the diagram, cache. So this is the part of cache here. So what is the purpose of cache in our CPU? So basically, we store the data, temporary data in cache, which are frequently used by our processor. Okay, for example, we are performing any operation on our processor, and there is one data which are frequently used by this processor. So we will not fetch these data from our primary memory every time. So this type of data can be stored in the cache memory, and it can be simply quickly fetched in the from the cache memory. Okay, so those data which we are using frequently, we will store into a cache memory. Okay, so our ALU can be fetch this frequently data very quickly from cache. Okay, so it increase our computation speed. So here you can see the next level is SRAM cache. This is called the static random access memory. And next level is uh, next level is DRAM, dynamic RAM. So dynamic RAM means our primary memory. So which we are generally listen that these things when you are purchasing any system, when you are purchasing any mobile. So these things is commonly used. So what is the RAM in your system? What is the RAM in your phone? So this is called the dynamic random access memory, and sometimes we call this DRAM as a internal memory or primary memory or main memory. Okay, so all these terms are used for this dynamic RAM memory. So this is the memory which are at the next level after the SRAM, and the capacity of this DRAM is actually from zero point 0.1 to 10 GB. So nowadays it is increases like 16 GB or 32 GB. It depends on our system. So this is the next level. If we draw the level diagram, so the first level is register, and second level is cache, third is SRAM, and next is DRAM. Oh, sorry, this part is the same. The cache memory means this is SRAM. Okay, this is next is DRAM, and after that, next one is SSD. Okay, so this is very popular nowadays. So the speed is very fast, SSD. So after DRAM, so if we see that the diagram in our architecture, so this is the first level, this is the second level, and after that we use the primary memory DRAM. And when we want to run any application, so the required data which will be executed for the application will shifted to our primary memory, and then that operation will be performed from the primary memory data. Okay, so this one is the next level, and after that second the next class is secondary memory, DRAM, and next one is SST. So I've discussed this. This is basically called the external memory. There is one more things. All these three are the volatile memory. Okay, so volatile memory. Volatile means if if our system power is off, all data will be removed, all data will be deleted from this memory. So this is not a permanent memory. When the power is on, all data will remain in our memory, but once when the power is off, all data will be deleted from this memory. Okay, so that is called the volatile. The remaining things which are coming in the external storage classes, those are non-volatile memory. Okay, so first is SSD. So capacity of SSD is high compared to the DRAM. We generally nowadays 1 to 100 GB or more than 100. So currently now in days 5 till 501 TB SSDs are available in the market. So the next is some year before we generally use this magnetic disk. HDD, hard disk drive. Okay, so capacity is high to store. That means capacity high means the cost is less. So we can take the higher capacity for our systems. Okay, so because the SSD cost is high, so generally we cannot afford the cost of the high size disk. So because of that, we generally use the lower storage capacity for the SSD. Okay, this is the next level, magnetic disk. And next one is optical, magnetic. These are the remaining categories. Generally, these categories are used for the backup system. Okay, so these main starting first things. Okay, so these first five are generally used in our system, but the remaining things we can use for the backup system. So one second. Yeah, SSD also comes under the secondary memory. Secondary memory, and we can also use the term external memory. Okay. Yeah. So these are the different type of category of memory, and what are the level of these memory. You can see that. So this is level 0. We can generally use the level 0 for the registers 1, 2, and then 3, then 4. This type of level we can assign, which are closer to the processor. Generally, we assign the 0. We are starting from the in that way. So after that, how we can measure the performance, how we can compare these memory types. So there are some parameter we generally used for that. The first parameter is latency, and this latency is represent the time to read first value from a storage locations. Okay, so how much time it is taking for the reading the first value from the storage. For example, if we are requesting anything to from our memory, and how much time it is taken when we are getting the first value from our storage. So you can see that here the what is the order. So that means lower is better. So okay, so that means lowest time is better. uh, those memory are providing the fetching speed very fast. That means it is taking less time, and that is better. So register are very fast. Okay, so this is very closer to the processor. So generally we used for that. So this is the fastest. Okay, next fastest is SRAM, static random access memory. Next one is DRAM, dynamic random access memory, and next one is SSD, and next one is STT. So this order is based on the speed for fetching data. Okay, so this is the smallest one, and this is the largest one. So first one is latency, and next is throughput. Next parameter we generally used as a throughput. Throughput means number of bytes per second that can be read. Okay, so from memory, how many bytes per second we can read. Okay, so that means higher is better. Okay, so higher number of bytes we can read per second from any memory, that means that which are better. Okay, so here this is the order. So DRAM is the highest throughput, then SSD, then HDD. Okay, so then yeah, SSD, then HDD, and generally we not use this registers and SRAM because it contains very small amount of data. Okay, so generally we store the data in our this type of memory. So DRAM, SSD, and HDD. You can see the order of the throughput. Next one is density. Density means how many number of bits we can store in per unit area. Okay, so if okay, so and per cost. So number of bits stored per unit area oblique cost. What is the cost for that? So higher is better. That means small area we can store higher number of bits. That is better. Okay. So in that way, we can see that what is the order. HDD contains the larger data in small area. So this is the first one. Next is SSD, then DRAM, then SRAM, then registers. Okay, so this is the order of the density. So these are some parameters where we can compare our storage system, storage memory. So CPU has as many registers as possible. So this it depends on our CPU systems. So how much registers are required? Generally, in the starting state, we generally use the approx 8 registers. So it can be vary and depends on the processor. So but not we cannot use too much. Okay, so because if we will use the too much registers, so definitely cost will be increases for our system because the cost is high. Okay, and so this is the next one is backed by L1, L2, L3 cache. So this is basically a category of the cache. So generally we use these 2 3 type of cache in our system. So this is the next one is generally we use 8 GB, 16 GB, or 4 GB RAM in our system. And next one is the backed by the SSD. So generally, so for example, if you want to purchase any server, so generally today SSD speed is fast. So generally we prefer the SSD in our server. Okay, so compared to the in the old, so few year before, generally server they provides the HDD. So nowadays they are also providing the SSD. So we can select this SSD when we are purchasing any server for our deployment. So next one is backed by HDD for high capacity. If we want to store much data, so then we can prefer HDD. And next one is the backed by long-term storage of or backup. So if you want to store our data for long term and for backup system, so generally we use the remaining things, remaining memory type. Okay. So backup and cold storage is basically generally today we are using this cloud things. So backup and archives, hugs amount of data. If you want to store hug amount of data, or not required to read very frequently, so then we can store these type of our data in this type of storage location. So these are some Google, Azure, Amazon. These are providing. Here latency is high because they are storing our data on the cloud. So if we want to fetch large data, so it will take some time. So the cost is very low. Impact on application development. Yeah, so definitely we are learning application development course. So this is important when we are selecting a server. So everything we need to verify that for purchasing any server, what is the RAM they are providing, what the SSD, what are the space they are providing, so what type of memory they are providing. Everything are important when we are working in as a application development. So also these are the important things. So this is the memory part. Now we will check that the activity question based on that. So first one is this. Okay, now tell me the answer of first question. Which of the following statement is a true about CPU and registers? Can anyone tell me? So which options are correct?
First one. First one.
Okay, so first statement is registers are used to store data and instruction that are being used immediately by the CPU. Okay, so this is true. So this stores the data which are directly used by the CPU. So that contains this data. So the next statement is registers are located on the CPU. This is correct. Yes.
Yes.
Okay. We have already seen our data structure, computer architecture. So this is correct. Next one is registers are used to store permanent value with the CPU. This is not correct. Okay, so all are the volatile memory. Registers, SRAM and DRAM, all are the volatile. So when the power is off, then our data will be removed. Next one is registers are present in a small number in any processor. So this is also a true, because we cannot take a large number of registers because of the cost issue. So this is also a true statement. So first, second, and fourth option are true for the first question. Next one is, what does SRAM stand for? So we know that static random access memory. This is the correct one for that. Now third one is, which of the following statement is a true about cache memory? Cache is usually implemented using SRAM, static random access memory. So is this correct?
Yes, sir.
Okay. Yes. So cache memory is limited in capacity but better than register. This is correct.
Yes, sir.
Yeah, cache memory is better than in capacity. Okay. Cache memory is limited in capacity but better than register. Uh,
Yes, based on capacity,
yeah.
cache
So
is better than this.
yeah, capacity wise it is better. Okay, this is true about the cache memory. Okay. Yeah, next statement is cache memory lies within the memory hierarchy. Yes, this is also correct. It is also so. Next one is, it is used to hold data permanently that the processor is likely to reuse. So last option is not correct. Basically, processor. So it holds the data which processor is likely to reuse, but not permanently. Okay, temporarily. It is stored the temporarily. So the last option is not correct. All the remaining three are correct. Next one is, which of the following storage elements has the highest storage capacity in general? Which one?
HDD.
Yeah. So if you see that this is the smallest one, DRAM is the next one, then SSD, then HDD. So HDD is the correct answer for that. Next one is fifth. Which of the following is usually referred to as random access memory in your computer? So random access memory, generally we used RAM. So which is preferred? So what is basically called
DRAM.
DRAM? Yeah, DRAM is the correct for one. And next question is, okay, just Which of the following statement is true about SSD? So SSD use flash-based memory, which is faster than the traditional hard disk. Yeah. Okay. Next one is SSD are non-volatile. So SSD are uh, SSDs are non-volatile. Okay, this is correct. Mhm. And SSD has a large storage capacity and can store up to several hundred gigabytes. Okay, this is also right. So all three statements are correct. So last option is given as all of the above. So this is actually a MCQ, but last option is saying that all of the above is possible. So all three options are possible, correct for that. Next one is which of the following is are the valid storage device which stores data on the computer. So this is the HDD. Which of the following is a valid storage device which stores data on the computer? So HDD, SSD, printer, RAM. So there is no meaning of printer here. So printer is basically the used for the different purpose. So all first, second, and fourth is the memory type.
Why RAM is the correct answer?
Sorry.
So I think RAM should not be the correct answer, but because RAM is not used for storage, instead it is used for some other purpose, like exchanging the data between during the process. We don't store,
Yes, but still we are storing, na.
but sir, it's not a
This is
storage
not this is
device.
not a temporary, but still we are storing for a particular time. So that is coming in the storage.
Okay.
Okay. So here we this is not mentioned for permanent storage. Okay, so if it is mentioned that which is used for the permanent storage, so that times we can see that RAM is not. But here it is generally asked for the valid storage device. Okay, now question number 8 is which of the following metrics are used to compare different storage element? So what parameter we have discussed here? So latency we have discussed, throughout throughput we have discussed, density. So all of them are the parameter to compare the different type of memory. So all the last option are correct. Now next one is which of the following sequence of storage device is correct in the context of latency? Okay, so latency means which one is the faster for accessing the data. Okay, so which one is the correct for that? So register, definitely register is the first level. So we will start from the register, then SRAM. Okay, so first option is not correct. We are starting from the SRAM and register is coming in between. So but second and third option we can compare. Now the second value, second type of so register, then SRAM. Yeah, this is okay. But in the third option you can see that HDD are coming there after register. So this is not correct. So second option is correct. Register, then SRAM, then DRAM, then SSD, then HDD. So this is the correct order with respect to the latency of uh, our storage device. Okay. So these all are the activity question for lecture one. I think it is all are clear. Any doubt? Okay, so let's move to the next part. Okay, so not here. Sorry. Data search. Okay, so now we will move to the data search because we want to explore the database things uh, for our backend system. So if we are developing a application, so definitely we need a database. So how database is actually work and the what operation we are generally perform with the database. So the basic operation we perform with the database is a search. Okay, so we will understand what is the search thing, so how we can perform this search operation. Before searching, we should know about these things, big notations. So I think how many of you have completed the PDSA course? Okay, friend. Okay, so those who have completed PDSA course, definitely they know about this notation things. So those who have not done yet, I'm just explaining the little bit about this notation things. So basically, for if we are writing any algorithms, okay, so here we are talking about the searching. So if we are writing any algorithms for the searching operations, so how we can compare the different type of algorithms, which one is better, which one is not better. Okay, so to compare the algorithms, generally we use the two types of parameter. First is time and second is space. Okay, so how much space our algorithm is taking during the execution, and how much time our algorithm is taking during the execution. Okay, so generally we so space is not a bigger issue, but generally we use the time complexity to compare our algorithms. So time complexity means, what is the time complexity? So time complexity means when we are running our algorithm, so how many number of steps it is taking uh, in the terms of input size. Okay, so for example, if we have a list, like this. So for example, if we want to perform a searching operation, okay, and this is, so what is the size of this list is 1 2 3 4 5 6 7 8 9. So size is 9, so we can say that n is 9. But when we are performing our algorithm, so how much steps it is taking to find our elements. So for example, if we are searching a element 3, okay, and then we are using a naive approach, so we are just starting from the first element, we are comparing from the first element, and then we are checking. Okay, so in that way you can see that for searching, so we are comparing that 3 is equal to 1, no, then we will move to the next element, then 3 is 3 equal to 2, no, then in that way we will move to this position. So one comparison we are performing here, next is here, third, fourth, fifth. So after fifth comparison we are getting our output. Yes, 3 exists in our list here. Okay, so that means if we are performing our algorithm on the input size n, so how many number of steps our algorithms are performing during the execution times. Okay, so generally time here, time is not representing a actual time, clock time. It representing a computer time. So computer times is basically a number of steps. Okay, so how many number of steps it is taking for complete our execution. So we can find out these total number of steps manually, but this is not possible for every algorithms, for every situation. So generally what we will take, we generally calculate the function for that, fn, and we can represent that if our input size is n, so what is our output size. Okay, so for example, fn, so here n equal to 1 is given, so 10. I'm just giving a small example here for I in range n. Okay, and then we are performing some print statement here, I. Okay, so now you can see, if we are running this program, if we are giving n equal to 10, so how much time this print statement will perform? 10
10.
times. Okay, so here you can see that if we increase this n to 100, okay, so this print statement will be performed 100 times. Okay, so that means if we calculate the number of steps for n, so we can say that this is a simply assignment, it is a unit operation, so we can say that this is a unit operation, but the second line is running, it is depend on our input. Okay, so this second line is depend on our input n, and so if we are providing n value equal to 10, then this for loop will be executed by uh, executed 10 times. If we are providing 100, that it will execute 100 times. So this means this statement is depend on our inputs. So we can say that this input will be perform, so this for this line. Okay, so this I'm talking about this line, So this line will be executed n plus 1 time. We can see that. Okay. So next thing, this print statement. Why we are taking this n plus 1? Because 10 times it will be executed. That means 10 times the condition will be satisfied and we will enter into a inside it. But the next one, when the loop will terminate, then the our I will become the out of range, which we are passing here n. So one more time it will be performed when the condition is not satisfied, and then we will break our loop. So because of that, we are mentioning here n plus 1, and we will enter n times inside this for loop. So that means print this line will be executed 110 times. Okay, so we are generally taking n times. Okay, so we can sum all the steps. So 1 plus n plus 1 plus n. Okay, so we are getting 2n plus 2. So this is a actual number of steps which our program is taking for n input. Yes, okay, so we are representing in the terms of n. So if we are passing any value of n, then we can calculate the total exact number of steps. So for complexity, we generally use the highest order of n, highest magnitude of n. We select for the complexity. Okay, so theoretically, this is not an exact. So complexity is not represent the exact number of steps, but it represent the highest order of dependency of our input. So here we will select this n. So that means we will, so for representing this, so for example, if we are representing this omega notation, so this is generally called big O notation. So sorry for omega, this is called the big O notation, and this represent a upper bound. Upper bound means our algorithm will take maximum this time. If we are representing a our complexity with big O, that means this is representing a upper bound. That means our, in any case, any type of case, our algorithm will take this maximum time. It cannot take more than this. So here generally we use this big O notation to represent our complexity. So for this program, we can represent the complexity fn equal to big O n. So that means this is representing a dependency of our, if we are providing n, then total number of steps will be proportional to n. So same things if we will use the nested loop. Okay, if we will use the nested loop inside this program, so for example, this we are taking a nested loop with the range of n, and then we are performing print operation. So in that case, you can find out that the first statement will be performed 1 time, second will perform n plus 1 time, and third for loop will be performed. So this nested for loop will be performed n time for every value of I. Okay, so here we can see that the third loop will be performed n into n plus 1 time. Okay, so for every value of I, this nested for loop will run n times. So we can see that so total, this is the time that it will be performed, and this print statement will be performed n square time. Okay, so for every value of I, it will so this print statement will be print n times. So we can see that n into n times n square times. So here if we represent this fn, then we can say that n square n into n plus 1, then n plus 1, and then plus 1. Okay, so we can represent in that way. So n square plus n square plus n plus n plus 2. So 2n square plus 2n plus 2. So here we can simply represent this complexity fn equal to, what is the highest magnitude of n? This is
n square.
We will select
N square.
Okay, so that means this is the dependency. If we are providing n size of input, then our algorithm is taking the n square steps. Okay, so we are not representing the exact number of steps, but we are just representing the dependency. What is the proportional steps? Okay, so this is basically represent big O n square, and this is represented upper bound. So that we can say that our algorithm will take the total number of n square step, but it cannot take n cube. Okay, so this is the closest upper bound. Our algorithm can take lesser than this. Okay, so but cannot take more than this. So this things are represented by this omega notation. So in that case, so for example, if we are developing any algorithm, searching algorithm, so we can compare our searching algorithms in based of this time complexity. So here, so different types of complexity is given that can be achieved for any algorithms. So first is this big O 1. That means this is a constant time. That means if we are providing any input, our algorithm is not depend on our input, so it will take a constant time. So it may be performing 3 steps, 4 steps, any constant steps. Okay, so and that steps are not depend on our input size. Okay, so this type of algorithms complexity is represented as a big O1. Okay, so this is the smallest time. Okay, next one is log n. Log arithmetic in input set, if we are providing n input size and our algorithm is taking log n steps. Okay, so this is also a good, because for example, if we are providing 1024 input size and our algorithm is taking log n, that means 10. So this is very good, very nice. Okay, so this is also considered as a very good. And next one is big O n, that is called the linear size. So if we are providing n size of input and our algorithm is also taking a total number of n steps, so this is a linear. Okay, and next one is the, so this also considered as a in better way, but the next one is, this is the n to the power k. This is called the polynomial, and this is generally not come in the good complexity. So if we are providing n size of input and our algorithm is taking, for example, n square, n3, and 4 in that way, so that means algorithm is taking large time. For example, if we are providing 100 size of input, then 1000 to the power 2. So you can see the total number of steps. It is very large. Okay, so for the large input, this value will be very large. Same things for the k to the power n. So for example, any things 2 to the power n. So that means this for the large input, this value will be very, very large. So this is the order of the growth. This is the smallest one, this is the largest one for the large input. We compare the complexity for the generally for the large input. So this one is the better. Okay, so this is the complexity classes. We can categorize the complexity. And next one is searching for element in our memory. Okay, so for example, if we want to search any element in our memory, so basically we store our data in memory. It may be in the data structure, it may be in the database. So first we will discuss about the data structure. Okay, so for example, if our elements are stored in memory in a data structure, list or array, anything, and we want to perform our searching operation. So here some condition is given. First condition is unsorted data in linked list. So what is the linked list here? Now those who have not study this PDS course, I think they don't know this linked list concept. So linked list is basically we store our data in our memory. So every data element can be stored in any location, but we link all these elements by a address. So for example, if our one data, so for example, this A value is stored any location in our memory. So for example, this is a 1002 address is in memory, and second element B is stored in another location. For example, the address of this is 4010. Okay, now third element is like C, it is stored in the another location like 6020. Okay, so our data element can be stored at any location, but we generally organize these data in a structure, and we store the address of each element so generally we store the next element address at the place of first element. Okay, so here we are storing the address of this B element at the position of A. Same things, we will store the address of C at the place of B. So we can store this address like this. Okay, so that means A contains a value and A also contains a address of next element. Same thing, this area contains a B value and it also contain a address of next element. So same thing we repeat it for the every element. Okay, so in that way data elements are stored in the different location in our memory, but we can access if we generally contain the address of first element. Okay, so we can say that this is a head and this contains a address of first element. And after that, if we want to traverse all the elements, we generally traverse, we can start from the first element and then we can traverse all element in the list. Okay, so but we will always start from the first element. For example, if we want to access this third element in our structure, so we will start from the first element, then we will move to the, we will check the second element address from here, then we will move to the next location, then we will read the next address of the next element, then we will move to the next location, then here we will find out the our searching element. So in that way we will always start from the beginning and then we will compare our element one by one uh, using this linking of address. So this type of structure is called the linked list. Here we are maintaining a list and we are linking all the elements by a address. Okay, so this type of structure is called the linked list. And in this type of structure, if we want to search any elements, so we have to start searching operation from the first element every time, because we cannot directly fetch the third element or fourth element, because we have no we are not storing address of the third element in any variable. We are just storing the address of first element. So in this case, we will always start from the first element, proceed step by one. We will read the address of every element, then we will move further. So compare each element, stop if found, and return location, otherwise not found. Okay, so in that way, for example, the worst case things. For example, if we are searching a element D and we have a list of 4 elements, then we want to search a list, search a element D. That means we will start from the first, then we will move to the second, then third, then fourth. So that means we have to traverse all 4 elements to search D. So that means if our element are n, so that means we have to perform n number of comparison in worst case if our element exists in the last position. So we can see that the complexity is big O n for this operation in linked list. Okay. So now next is searching for element in memory. So this is a different type of structure here we are taking. This is a array. If you are using the Python, that we generally call the list. Okay, so this is a list. So what is the property of list? List provide the indexing. So 0 1 2 3 in that way it provide the indexing. So here we can see we can use this indexing to, so for example here this is the different situation. If our data in unsorted way, so for example if our data like this, so 8 1 6 2 5 4 3 9 10 in that way. Okay, so here there is no pattern in the data in the storage. Here we have index for every element, but we cannot use this index for efficient searching, because our data is not managed properly. There is no order in our data. So in that case, our searching element can exist at any position. Okay, so we have to perform linear searching in this type of situation. So start from the beginning. For example, if you want to search 9, so for example 3, so we cannot direct check the 3 index because our data is unsorted. It can be at any position. So we have to check from the starting. So we will start comparison from the first value, then second, then third, then fourth, in that way. At any time we will find out that the 3 is here. Okay, then we will return the index of that the 3 exist at this location. Otherwise it is not, if it is not exist, then we will return the not found. So this is so complexity for this searching is also a order of n, because in worst case, for example, if we are searching 10, Maybe it is also possible if a 10 is exist here and our 1 is exist here. Okay, so for example, if we want to search 1, so we will start comparison from the first element, we have to compare the second, then in that way we have to compare all the elements of our list. So that means we have to perform all n operation and comparison. So we can see that the worst case complexity for the searching in unsorted list or array is big O of n. Okay, so this is the second type of situation. Now the, for example, if our data is sorted in our list, okay, so now we can perform some efficient bit for searching. So like that, if our data is sorted like in that way, 1 3 4 6 9 10 15 20 30, okay, in that way if our data is sorted, then we can perform some efficient way for searching. So what we can do, so we know that there is one, we have some order. Okay, so we have one index also, 0 1 2 3 4 5 6, so 5 6 7 8. So we can use this index for search our element quickly in the sorted data. So because using this index we can directly check the element. Okay, so for example, if we want to check the fourth index element, we can directly access in constant time. So we can perform uh, so sorted data in array, searching for element in memory to stop it from location. Okay, so here what this step is given, the linear step, but I think in the next page it is given alternative way. Sorted data in a look. Okay, yeah, searching. So what we can do for this type of data, we can directly check the middle element. Okay, so we can directly check the middle element. So for example, if we want to search 20, okay, so we don't know what elements are in our list, so we directly check the middle element, fourth index, and we check that our searching element is greater than the middle element or lesser than the middle element. If it is greater than the middle element, then we can discard the this part. Okay, we can directly discard this part for the searching. Okay, so that means our element can be exist on the right side but cannot be exist on the left side. So there's no need to search in the left side area, so we can directly remove the half part of the searching. So initially we are searching from the n element, then in the next step we are just remove the half element. Okay, so that means our remaining elements for searching are, for searching we have only n by 2 elements in the next steps. So same things we will repeat. We will just compute the middle index from here. So 5 to 8 we will calculate the middle index. For example, if we are getting 7, and then we can check that our 20 is exist. Okay, if our element is exist at the middle index, then we can return the true. Otherwise we just compare that our searching element is greater than or lesser than, and based on that we can move accordingly, and we can discard the remaining part. Okay, so in that way, so how the, what is the maximum time we can search the element. So for example, if we have a n element initially, then in the next level we will discard the half element, then that means ny2, in the next ny4, then next ny8. In that way we will reach at the one element. So here you can see that we are decreasing in that way. Every time we are removing half part of the searching area. So that means we can search our element in log n steps. So for example, if we have a 8 element, that means 8 by 2, then 4, then 2, then 1. Okay, so this is representing a 2 to the power 3. That means 3 comparison we can search the our element. So this value is representing in log n. So total number of steps, if we count this 1 2 3, so that means total number of steps are log n is required. Okay, so that means we can search our element in log n step if our elements are sorted in our data structure. Okay, so this is represented here. sorted data in a array, so we can just directly compare the middle element, and then we can discard the lower half or upper half, and then we can perform this type of searching repeatedly again. So in that way we can achieve our searching in log n time. So this is much better to the linear searching. This is generally called the binary search. Next one is problem with array. So the problem is with array. So here this array is basically used for the C programming. So in that way, size must be fixed ahead of time. So in Python, is if we generally use the list things, so we can increase the size during the running time. But in the traditional language like C and C++, we have to assign the size initially. Then we can use only that size. Okay. So adding new entry require resizing. Can try oversize, but eventually maintaining sorted order. So yeah, we have to maintaining the sorted order. So at any time we want to store if we want to store new element in our data structure, and so we have to maintain the sorted things. So because of that, this operation will take a larger time. For example, if we have a list and we have elements like this 1 3 5 6 7 8. Okay, so then if we want to insert a new element 2 here, okay, that means we have to shift it all element one position back. So this operation will take a order of n time. So if we are inserting a element in middle position, so that means we have to shift it all element one position on the right side. So that operation will take the largest step. So this same things for the deleting. If we want to perform any delete operation in middle position, so we have to shift all elements one position to the left. So this operation is also a costly operation. So this is the problem with our list data structure. And next is alternative of binary search tree. We can also maintain a binary search tree data structure. So binary search tree basically we can create using a linked list things. Linked list, that means I have discussed with the linked list example. So same things we can create a binary search. What is the meaning of binary search? This is a tree. Tree is basically generally we start from the one root node. This is a top element, and this is called the root node. And we can arrange our data in a particular order using this tree. So how we can maintain this order? So I think one that diagram is given. Okay, so no, not given. Yeah. So for example, if we have any data, so we can take, so this is a binary tree. Okay, so we can take a maximum 2 child for that. So there is one possible same thing in that way. But here one condition is given: every left child should always be lesser than the parent node. This is the first condition. And second condition is every right child node should be greater than the parent node. So if our tree following these two properties, okay, so left child should be lesser than the parent node and right child should be greater than the parent node. So this condition should be satisfied by each subpart of the tree. So that is called the binary search tree. Okay, so for example, if I am representing in that way, so 100, this 50, then 20, and then 60, and then 200, and then 150, and then 300. Okay, now you can see this property is holding for every subtree. So here you can see the 20 is lesser than this 15. Now 60 is greater than this 50. Same things, 50 is lesser than this 100. Okay, so 150 is lesser than 200, but this 300 is greater than 200. Okay, so same thing, this property is also hold with the whole subtree part. So for example, we cannot say that so like this. So 150 here we cannot say that here. So we can say that we cannot take 90. Okay, this 90 is satisfying the condition for this one, but it is not satisfying the condition. So every node which are coming on the right should be greater than this. Okay, every node which are coming on the left side should be greater than the top node. So this property should also be satisfied. Okay, so if our data is stored in that manner, so we can efficiently use this for searching. Okay, so how we can so same things, so like this type of structure, if we want to, so you can see that here the elements are 7. Okay, so elements are 7, but we can find any data, in 3 steps. For example, if we want to search this 300, okay, so we will just check the root node, and then we will compare the 300 is lesser than and greater than. So if it is greater than, then we will discard this left part. So we will move to this part. Okay, so same things we will compare again. Now 300 is greater than 200 or lesser than. So it is greater than, then we will move to this part. Now we will get. Okay, so same things, the height of this tree is log n if this is a balance. Okay, so here you can see we can draw this type of tree by connecting in that way. So we can also store 1020 3 element with the height of 10. So that means if height of 10, if our tree height is 10, we can store maximum 1023 elements. For any element we can search from this 1023 element in 10 steps if our data is stored in this way, in this order, in this tree. Okay, so this is not a linear data structure, this is a non-linear data structure. It can be implemented using a linked list concept. So here we can achieve this log n complexity for searching if our data is managed in that way. And in this, so in this type of data structure, we can also insert or delete in log n steps. Okay, if we want to insert new element, simply same things. For example, if we want to insert 400 value, then we will traverse from the root. 400 is greater than 100, so then we will move to the right. Then same things we will compare here. Now 400 is greater than 200, then we will move to the next step. If 400 is greater than 300, and there is no node available here, so at any time when we found the empty space, we will add this 400 here. So that means we are traversing the log n height for inserting a element. So that means we can insert element in log n steps. Same things for the deleting. If we want to delete any element, so we can also perform some deleting operation. So we can achieve this delete operation in log n steps. So we can achieve this log n complexity for every type of operation if our binary search trees is balanced. So same things, but what is the problem for this binary search? If we are simply talking about the binary search, so there is one problem. Maintaining sorted order is easier, growth of tree, but self-balancing is required. Okay, so sometimes, for example, if our elements are coming in that way, 1 2 3 4 5 6, okay, and then first thing, if one is coming, then we will create a one first node. If the second is coming, definitely two is greater than one, we will add here. Okay, then 3 is coming, then we will add 3 here. Okay, because 3 is greater than 2. Same things, 4 is coming, 4 is greater than 1 2 3, then we will add here. Okay, so we are creating a binary search tree, but in this order our binary search tree is creating in that way. Okay, so 4 5 6, like say, okay, 5 6. If our binary search tree is creating in that way, so there is no benefits for that. Okay, this is similar to a linear array. So in this type of binary search tree, we cannot achieve the log n complexity because our height of this tree is also a n. So our binary search tree should be a balanced tree. That balanced tree means the left subtree height or right subtree height should be approx equal. Okay, that is called the self-balancing. So at the time of insertion, we have to apply some balancing algorithms to make our binary search tree balance. So some algorithms are available. So red black tree, AVL tree, B tree. So that is used for the self-balancing. Create the self-balancing binary search tree. Okay, so this is also a extra things for the uh, binding search things. Okay, so we are not going in these algorithms because these are very deep, but this the basic purpose of these algorithms are to make our tree is a balanced tree. Alternative binary search tree, we have mentioned this. Self-balancing, then has there is one more type of things, data structure we can use. So here we are just achieving the log n complexity, but one more type of data structure we used to store our data and search our data. Okay, this is called the hash table. Hash table is basically if we are storing for example, if we want to store 20 in our memory, so how we can store so how we can decide the what location we should store this 20 in our hash tables. For example, this is our hash table, and this contain a index like this: 0 1 2 3 4 5 6 7 8 and 9. Okay, so for example, if our hash table size is 10 and these are the index for this, and we want to store 25 in our table, so here we can use some another trick to store our data and search our data. Okay, so that is called the hash, and we generally use the hash function for that. And this hash function is basically a mathematical formula we can use. So this hash function is taking our data as an input and it generate an index as output. Okay, and at that index we store our data. Okay, so for example, if I am taking this a small hash function, so this is like a k mod 10. Okay, so this is our k value which we want to store in our hash table, and we are just giving this k value in our hash function here, and this hash function will generate a address index. So if we are passing this 25 mod 10, it will return a 5. That means we will store our 25 at a 5 index. If we want to store 33, then we will use the mod 10, and then we will store at a 3 position. Okay, so it will return 3 index, so we will store here. So this is the basic idea of the hashing, and same things. So this approach we are using for the storing, and same things we will use for the retrieving. So for example, if we want to search the 33 exist or in our hash table or not, so we will apply we will just give this 33 to our hash function and check that what is the index for that, then it will return the 3 index, and we will directly check that 33 exists on this 3 index or not. Okay, so we will check the 33 if it is empty or if other elements are exist, so that means our element does not exist. So that means in constant steps we can find out our elements. Okay, so this is called a hashing things, where we are generating a index using a hash function, and we are also searching index also searching element using this same hash function, which we are using for the storing. So in that way, so in Python, actually dictionary, you have already used this dictionary data structure. So dictionary data structure use this concept hashing. Okay, hash tables. So this actually return our data in a constant time. Okay, but there are some collision and other things are exist. So because collision means if we are getting the same index for more than two value, so for like the 25, same for 35, it will also generate a 5 index. That is called the collision. So some collision resolution techniques are used for the hashing. So that is also a deep things to discuss. So this is the basic idea of hashing, how we are just getting the index and how we are storing our elements and how we are searching our elements using in constant time. So this is another way of searching. So log n we have seen, and constant we have also seen. Okay, and the linear big of n we have also seen. This is the different type of searching algorithms which is taking a different time. So this is the next things. Now check the question based on that. Activity 2. How many steps are required in binary search to search for an element in memory when n numbers of element is stored in the sorted format in an array? Okay, so here the elements are stored in sorted format. So what will be the answer?
Log n.
Log n. Okay. But there is one condition, I think, if our binary search tree is balanced here. Okay, so this is also important. If our binary search tree is not balanced, then it will take a order of n time. So for an array with n elements, which of the following Big-O notation will give us result as far as the smallest change in input is concerned? Array. Okay. So if we are performing the insert operation, then what will be the complexity for that? Sorry. Okay, for an array with n elements, which of the following? Okay, so this is asking, talking about the worst complexity. Which one is the highest? So which one is the highest order of n? This is a k to the power n. Okay, we have seen that the order of growth for the input n. So this is a k to the power n is the highest complexity. Okay, the next one is, if n is a constant and k is the input size, then Big-O n to the power k is a which type of category that is comes n to the power k? This is a polynomial. A polynomial, no, sir. At n to the power k. This is comes under exponential. Next one is, which of the following search type can be solved with log n time complexity? Okay. Can anyone tell me which of the following search type can be solved with log n time complexity? Unsorted data in linked list. So we have seen that if we are maintaining our data in linked list, we cannot achieve the searching in log n time. Unsorted data in the array, we can also not achieve the searching in log n time with the unsorted data. But if our data is sorted, that we can achieve the log n time searching using the binary search. And last one is, let a data set contains n number of entries. If an elements in the data set is found in k steps with the help of binary search, then which condition is true? Okay, that means we have n number of elements. We are searching the elements using the binary search. So which condition is the true for here? So number of steps in the binary search will log n. So definitely log n is lesser than n. Okay, always. So we can say that this third step, third option is correct. K is less than n. Okay. This is clear to everyone. Okay, so someone is also posting in the chat box. Okay, fine. So we'll move to the next. Database search. So now we come to the next stage, database. So database is basically we are using in the application development. So what database is? So generally, the popular database is we are using currently the RDBMS. So relational database, and the so what is the form of this database? Is a tabular form. So that means our data is represented in the tables forms, and then table contains a row and columns, and columns represent the attributes and row represent the entity. That means row represent the information about one entity. Okay, so this is mentioned here, tables with many columns. Okay, so now our data format, like we use generally like in that way. Okay, so this represent the attributes. So for example, id, name, age, okay, city, phone number, address, in that way. And after that, every row represent the information of one entity. So this row is represent the information about one. So for example, this is a student table, and every row represent the information of one student. So what is the ID of that student? What is the name? What is the age? In that way. Okay. So table with many columns. Want to search quickly on some columns. So for example, definitely if we are maintaining any database, so later we will perform some searching operation. So select operation definitely we will perform. So how we can achieve this select operation fastly? So these things we will discuss in this slides. So maintain index. So okay, so want to search quickly on some columns. So for example, if we want to search anything in our database, and how we can uh, quickly search any column. Okay, so there is one term used, maintain index of column to search on. Okay, so for example, if we are creating any table, so by default the primary key field, okay, so it is created as an index by the our database engine. One second. Just a minute. Yeah. Okay. Sorry. So here table with many columns. So here if we want to search any in any particular columns, so how we can search quickly? So that means how we can. So you have already seen some algorithms before that. So binary search, hashing, and linear search. So in that way, for example, if our tables contains the 10 to the power 6 or 10 to the power 5 quantity of data, number of rows. So in that case, if we want to perform any search operation, okay, so for example, if we are searching a name, so if we are using a linear search for okay example, if we want to perform a linear search, so we have to traverse all the 10 to the power 6 names in this column. So how the index help for the quick search? So basically id. Okay, so if we are creating any column as a primary key, so by default our database engine will create as an index. And what is the meaning of index? Index is the meaning. So basically, meaning of the index is it will create a separate. So for example, if we have a ID for each row. So for example, if we assign a ID for each row, so 1, 2, 3, 4 like this. So this is representing a row number. Okay, so and in the separate list we will just maintain a sorted sequence of id. Okay, so for example id and row number. Okay, so in that case by default this primary key, if id number is not in the sorted order, so by default our database engine will create an index for this id, because this is a primary key. Index means it will maintain a sorted order for that. Okay, so for example our id is like this: 10010, 1005, 5, 1004, 1001, in that way. But our index, it will maintain like this: 1001, 1004, and 1005, 1010. Okay, and it will also store a corresponding row number. So 4, 3, and then 2, and then 1. Okay, so this is created automatically, but when we want to search based on this index, so definitely we can apply the binary search for that. Okay, so here our data is sorted. So we can perform binary search on that, and based on the binary search we can directly retrieve the row number. So for example, if we are searching a 1005, then we can directly quickly search this 1005 in our index, and then we can read the row number. Okay, so then this is referring to the, so this is like this. Okay, and then we can directly access the particular row number which we want to search. So same things, we can also make another column as an index. So for example, in our application, we are frequently perform searching in a name column. Okay, so that means we are getting the data in from any form. We are just getting the name from any form, and then we want to search that name in our database. So if we are performing frequently this type of searching, and our name is not assigned as an index, so that means we have to perform the linear search on that. Okay, so because this type of index is not created for the name, but we can make this name as an index if we are performing searching on this particular column. So we can make this column as an index. So same things, when we are creating this name as an index, so same type of table will be created, and the same type, so these names will be arranged in the sorted order, and all the corresponding row will be assigned in the same way, and then we can perform binary search. So we can achieve this fast searching using this index, which mostly database provided. So we can make any column. So generally we don't want to make the large value columns as index. Those columns are storing small value, because during the creation of index, if we are taking the large value like binary data, so for example, if we are storing a binary image, if we are storing a image in any column, so our image will be stored in the form of binary stream. So we cannot, so this type of column we generally do not make as an index. Okay, so smaller value columns, those are containing a smaller value in as a value. So we can make that column as an index, and that index will be created. And then when we can apply the binary search type of algorithm, and we can quickly search any data using this index. Okay, store a sorted version of columns, so that is defined by in that way. So needs column to be comparable, integer, sort, string, date and time. So that means we can sort the strings also, we can also sort the dates, integers. So this type of column we can make as a index. Those are containing this type of value, but that should be a smaller one. So long text field are not good for index. Binary data are not good. Okay, because the length of this data are very big. So these are the benefits of index in our database. So these are some things generally these MySQL provide for the index things. So how they can generate the index. Some are use the B tree concept. So some are use the hash index, hash indexes. Okay, so B tree is also a different type of data structure that also arrange our data using this index form. So we have already seen this binary search tree. So in that way we can traverse in a particular part. Same things in the B tree. In B tree we can store multiple data in one node, and each node also work like as an index. Okay, so for example, I'm just taking a small example. So like this, each node can contain maximum 3 value for this B tree. So like 5, 15 and 30, same things. Okay, no, not this one. So like 15, then any data is contained like this, 5, 20 and so 40, 60. Okay, so same things, 1, 2, 3, this is one type of B tree. So we can create a B tree. So this is a order of order 3 B tree. So meaning of that is here each node can contain maximum three value, and these every node also contain a child node, and this child node is actually represented as an index. So for example, here we are just connecting three children. Okay, so here our node is containing two value, so like this A and B. So we can take three child for that, and what the value of three child is representing. So each value of this in this child should be lesser than A. Okay, so for example, we consider this X, Y, and Z. Okay, so X should be lesser than A, and the Y value should be greater than A. Okay, greater than A and lesser than B, and all Z value are greater than B. Sorry, yes, so Z value are greater than B. So that means our data are arranging in that way. Okay, so for we are storing two value, we can consider three child. So definitely if we are taking one value, we can add two child. So this property should be fulfilled in our data structure. So in that way we can also search quickly, and we can store much data compared to the binary search. Okay, in binary search we were storing the one element in a one node, but here we are storing more than one element in one node. So same things we can search our element in the same way. So for example, if we want to search 2, then we will check the from the root node, if 2 is lesser than 15, yes, we will come in this part. Then here we will come 2 is lesser than 5, yes, so then we will move to this child. Okay, if we want to search, for example, 7 and 7 is exist here, so we will compare that 7 is lesser than 5, no, then we will check that 7 is greater than and lesser than 20, yes, so then we will move to this part. Okay, same things for this part, this things. So we can search our element in that way in the B tree. So this is also a type of structure, similar type of binary search tree. So we can store much data in this type of structure, and we can also use as indexing. So MySQL is basically use this type of B tree and hash index for our index, for their index. So yeah, if our so these are some query which we generally used in the SQL, and how we can achieve this index things. If okay, so what type of query we can, which are index friendly. Okay, so that means we can achieve fast searching using index. So you can see that if our data is searches, if our data, if we have created any column, so like for example this key column, we are talking about this key column. If we have created the index for that, and then we are just passing this value. Okay, so this is like a string matching. So here we are just comparing this the value which are start from this Patrick. After that we are taking this percentile. That means here it can be anything string. Okay, it can, the length of a string can be anything also. Okay, so same thing. So we are just searching a element, searching a rows from table this, and we are key columns like this. Okay, Patrick. If our data is sorted, so for example, if we have created an index of this key value, so then we can apply our binary search things. And then so we have the starting character. Okay, so we will compare the first character. Then if first character is matched, then we will check the second character and then third character. In that way we will find out the all elements which are starting from Patrick quickly. Okay, so that means this type of query is friendly, index friendly. Okay, because here the string starting a string is given, so we can filter our searching area using this starting part. Okay, so that means we can discard the large area for searching. So both are the index friendly, which is, so this is also starting string is given, so we can apply the binary search on the basis of these three elements. After that we have to apply the we have to check for all possibility for here. Okay, but for 3 element, so most of the element will be eliminated for the search. So that is also a index friendly. So basically we are performing a dictionary type of searching. So English dictionary, you have seen that if the first character is matched, then we will compare the second character in that way. So yeah, this one is the index unfriendly query. So for example, if our column is sorted alphabetically and we are just passing this value, okay, here the first part is percentile, that means it can be anything with the any length. So that things we cannot apply the binary search because the first character is or first character is unknown and length is also unknown. So we cannot apply the binary search for this type of. Okay, so because we don't know how many characters are coming before this p, so we cannot achieve the fast searching using index for this type of query. Same things for select star from table name where key column like other column. So here we are just comparing the key column like other column. So other column value can be anything. So same things here, the value is not defined properly. So we can also not achieve the benefits of complexity using index for this type of query. Okay, so this is a index unfriendly query. Same things. So index we can create for one column and we can also create a compound form. Okay, so compound index means we can create an index by combining one or two or three columns or more than. So like alphabetical order. So for example, the first column, then second column, then third column. First we will sort our elements by the first column. If for any particular single value, so for example, if we are just so for first column contains a integer data. Okay, so for example, initially 10 value we are getting 1 1 1 1. Okay, and after that for the second column, for this 10 value we are getting the different type of data like a b c d in that way, c f d in that way. So for every same value of the first column, we will sort the second column. Okay, so for this first column is contain one value, then two start. Then for every this similar value, we will sort the second column. Okay, for every similar value for the second column, we will sort the third column. So in that case, this type of index, compound index will be created. We are creating a compound index using 3 columns. So our data is sorted in that way. Okay, so for example, if we are searching any elements, so we will just check the first thing. And so for example, our first value is matched, but it contains 10 rows. Then we will check the second columns. Okay, in second content, if we are searching like a, and a is also contained by 5. Okay, that means we will check the third column. It is also sorted for this a. Okay, so for example, this is contain any sorted value. So in that case, we are searching our element using these 3 columns value, and our index is generated in that way. So we can quickly search, we can apply the search. So same things for the dictionary tag thing. If our first character is matched, and for example, if we are searching a c and y, so this is the 3 character. Okay, and this is representing a first column, this is representing second column, and this is representing a third column. So for example, if we are searching this type of string in our dictionary, so first we will check the a value. So maybe we will get the thousand of words with which are starting from a. Then we will check the c value from the all 1000 selected word. Okay, but we will discard all the remaining part which are starting from b c d in that way. So same things, we will check the c in the next. So maybe we will found 200 words which are starting from a and then c. Then we will apply the searching on the third column. So this is y. So that means in that way, same things we are performing on the columns. So that is called the multi-column index. Okay. So here also, so what are the multi-index friendly query and what are the multi-index unfriendly query which are mentioned. So index part one, yeah. So here one index one is given and index two is given and index three is given. All three index are given. So that means all three are required. So we can apply this type of query on multi-index. Same thing, okay. Same things here. Index equal to 1 or a equal to 10, and is given with index 2, okay. So this is also a possible thing. So if we are performing the, if index equal to 1 or a equal to 10, so this is a fixed value, a equal to 10, and what is a, it is not mentioned, if it may be any variable, okay. And so it is also index friendly because we are performing our searching operation on continuously columns, okay. So 1 and 2, this is also okay, and the operation is and in between. Index, so here index part 1, the value is given, and so same things here, the value is given, index part 1 and part oh, okay. Index part 1 and index part 3, yeah, it can also be applied, okay. So here we are searching on the first element, that means we initially we will search this hello value, and after all the hello value we will search this 5 value. So this will also reduce our searching time. So this is also index friendly. Same things for the next one, index 1 equal to 1, index 2 equal to 2. So that means if this one is 2 and here is also, so every time we are discarding our searching area by the index 1 first, okay. So this will discard the lots of data for searching, and then we are performing the second columns index. So here 2, here it is 3. So that means we can achieve the uh, so that means we can quickly search the data, okay. So these all are index friendly and these are the unfriendly. So here we are not, because our data is searches by first column, so first column, then second column, then third column, okay. But here we are giving the second column value, so we don't know the what is the first column, so we have to search all the data, okay. So because of that, this is not a beneficial query. This is not a friendly query for multi-index. Same things here, index equal to 1 or a equal to 10. So index not is used in both part of the where clause. So here or condition is given. So we have to check for every value. So we have to check 1 and then we have to also check. So any value, for example, this is true. So, and this may be true for the when the index value is not 1. Okay, so that data should also be retrieved. So in that case, we have to check everything. Yeah, this is also not a good query for the index. And then index part 1 or index part 2. Same things we are using or. So that means we have to check every value for this one. Okay, this part we can quickly search, but this or condition is given. So that means if any place we are finding out this index part 2 equal to 10, doesn't matter the what is the index value, okay. So that row should be retrieved. So this is not also a index friendly query. So if we are creating an index, so we should know about how we will use that index, how we will apply the searching, and we what column we are we want to search frequently. So based on that, we can decide what index should what column should be index. Yeah. So hash index only used in memory tables. So these are some things. Yeah. So hash index is basically used when we are just checking the exact element. We cannot apply the order by range. Range we cannot apply the hash index because hash index is calculated particular index value. Okay, so particular row it will be retrieved, but we cannot apply the query like this. So though retrieve the all rows, all the students which are greater than a 20 age. This type of query we cannot apply for this index. Same things for the order by. If prefix is not fixed, then we cannot use. Partial key prefix is available, then we cannot use because we cannot generate the hash value for that. So these are the problems with the hash index. So we cannot always use this hash things as as a index. So generally we use the binary search. So these are some of the things. Query optimization, all the database contains this part, but how query is optimized, how you can optimize the query. So these are available information available. So this information is available in the documentation. You can go through that if you want to check the deep information. So this is the third. So any query, if you have any doubt, you can ask in between. Okay, so these three questions are given. So a tabular data is compound index with three columns as index 1, index 2, and index 3. The value in the table are already sorted with index 1. How will they are further sorted? Okay. So yeah, so we are using the multi-index here using three columns. So we have the sorted our element based on the index 1, and how we can further sort this. Okay, so all value, so definitely if we have sorted the our data by the first column, then we will start from the second column when we are just making as a multi-index. So all value will be first sorted on index 2, and then entries within the index 2 on index 3. Yes, so this is correct, because we will apply the sorting on index 2 first, then all the similar value of index 2 we will apply the index 3. All value will be first sorted on index 3, so that means we cannot directly apply the sorting on index 3 without sorting the index 2. So this is not correct. All value can be sorted with only one of the indexes, so this is not also correct. For the sorting is not possible. So only option A is correct for that. In the context of MySQL, which of the following statement regarding hash table is correct? 2A. Okay. Yeah, so. Oh, where is it? Oh, sorry. So 2A, yeah, okay. So in the context of a MySQL, which of the following statement regarding hash table is correct? They are used only in memory tables. They can handle comparison. Okay, so this is regarding the hash. Yes, so they can handle comparison through range. So yeah, we cannot use the hash in the range. We cannot use the in the order by, and we can also not use with the partial key prefix. So same thing. The first option is correct. Next one is 3. Which of the following statement is correct about memory and storage? So storage is the component of a computer that allow us to store the data on a long-term basis. Storage, okay, so this is about the storage question. Storage is the component of a computer that allow us to store the data in a long-term basis. Okay, the data in the RAM remains intact when the computer is turned off. So this is incorrect. RAM is same as the hard disk, so this is also incorrect. And RAM is a temporary storage area in the context of, yes, this is correct. So A, okay, so just check the answer. So last one is correct and first one is correct. Yeah. Okay. So now move to the next part. Yeah. So SQL versus non-SQL. No SQL, sorry, non. no SQL. So SQL, you have already learned, this is stand for structured query language. So that means our database is properly structured in the tabular form, and then we can perform our query, so which are key defined, and then we can retrieve our data. Okay. Used to query database that have structured, properly structured in the tabular form. It could also be used for CSV file, spreadsheet, etc. So CSV and spreadsheet is also maintain the data in the tabular form. So we can perform the same thing as a tabular data. So this is the structure closely tied to RDBMS, relational database. So relational database, that is the type of our database structure. So the relational means our data is stored in a tabular form, and that means every column are related to each other columns. So that means each row is representing a related data for one entity, and tables of data holds relationship. Okay, so all the so tables internally contains the relationship, and then we can also maintain a relationship between the tables using some foreign key and other things. So all entry in the table must have same set of columns. Okay, yeah. So in SQL, so for example, if you want to store a data for large number of students, so I think the sir given one example. So for all students, we have to maintain the all attribute value. Okay. So for example, if we have assigned 10 types of attribute for student data, so maybe some things is not required for any particular student. Still, we have to assign a particular call cell for that student. Okay, we cannot so for example, any student contains only 5 attribute value and not contain the remaining 5 value, but still we have to assign some space for that. So that is tabular form. So that means all entry in a table must have same set of columns. That means all row contains a equal number of columns. So tabular database efficient indexing possible, use specified column storage efficiency, prior knowledge of data size. So some advantages they have: efficient index, using indexing we can perform the searching fast and this all these things. But what is the problem with the tabular database? So same things which I have discussed. Structure, good or bad, all row in table must have same set of columns. So this is a also a disadvantage for that. So for example, sir, I've given one example. So for if we are talking about any institute, if we are maintaining a data of a student, and there is one option host, student is a hoster or a day scholar. So maybe half of the students are hostler and half of the students are day scholar. So those students are hostler. So that means the day scholar fields will be empty for those students. So that means, for example, if we have a 10,000 student, and out of this 10,000, only 5,000 student took the hostel. So that means that for remaining 5,000 students, this value for the this hostel related things will be empty, because we have to take the column for all students. So that means some space is wasting, which are not required for some students. So this is the disadvantage for the tabular form. So here this is the example: student hostel mess, day scholar gate pass of vehicle, tabular column for mess, column for gate pass. So, yeah. So those students not contain any value for any particular type of an attributes, so that will remain empty. That will take some empty space. So what is the alternate way to store data? So first one is the document database. Okay, so document database, that means, so there is one format is given here. So this is called the JSON format. Here, so this is similar to a dictionary format which you have seen in the Python. So here some one list is given. Inside the list, one curly braces is given, and inside the curly braces some key value combination are given. Okay, so key is the representing a attribute, and value is representing a value for particular attribute. So in that way we can also store the information for each entity. So say you can see that the first part is contain the large value, so many value, but the second part is containing this less value. So those are not containing a much information, so no need to assign any space for that. So in that way we can achieve this wastage of space um, things. So we can also arrange our data in that way, and we can fetch this data using this key. So some type of database manage this type of document database. So some example is given. So this database also provides some query. So this is not a document actually, so there's no need to access this document via manually or any other things via any. So they also provide some SQL type of query, and then we can use the similar type of query to fetch this data, but in the backend they store data in that way. Okay, so they are not using a space which are not relevant for any particular entity. So the example for this type of database is MongoDB and Amazon Document DB. So alternative way to store, this is the dictionary. Okay, so has things. This Python is also maintained. This, so same thing. So the previous document is created by the JSON. This is a different type of object. I think you have already seen in the previous peak when the REST page you have learned. So this is a different type of data structure. Dictionary we can also use that. So map key to value. So same things, we can maintain the data in the dictionary or hash tables. So yeah, hash tables are used in the backend of dictionary. So we can also maintain our data in this dictionary format, key value combination. So some database also use this approach, Redis, Berkeley, DB, this type of data. You can remember these names, otherwise not required too much. Okay, alternate way to store. So here the column stores. So column wise we can store the data. So these are the different types of way to store our data. So some database are meant use this type of approach. So traditional relation DB store all value of a row together on the disk, retrieving all entry of a given row very fast. Instead, store all entry in the column together. So these data store the column wise data. Okay, so retrieve all value in a given attribute, age, place of work. So column wise this data is stored column wise. So like in any particular column we are storing only age, we are storing the place of work in that way. So if so same things, if those entity not contain any particular value, so we will not assign any entry for that in any particular column. Okay, so in that way we can also store column wise data, we can also store. So this some examples are given, HBase and Cassandra. And the another way is graph. So graph is also popular. So because for example, if you want to store a different type of information like network, okay, so friends network. So the social media sites, they are using the friends things information, which one are the friend of the another one. So this type of information, how they are maintaining? So they are maintaining using a graph data structure. So, so using the graph data structure, we can easily find out which one is the common in between. So for example, so generally this approach is used for the giving the friend suggestion. So generally when we access any profile of anyone, so this social media platform it gives this information which are the common between you and the which you are searching. So suggestion, friends, this type of extra information they are providing using this graph data structure. If we are managing all the data in the graph structure, so then that means we can retrieve this information very quickly. Okay, So how many label difference we have. So for example, if we want to search so your friends network, okay, so different degree number of outgoing edges, pathfinding more important than the search. So same things we can search quickly. So what are the label difference we have? So if we want to search any person, so how many common friends are there in between? Let's just do it. Yeah, okay, sorry for that. Okay, so these are the alternative way for the store our data. So we can also store our information in the graph, and we can use according to our requirements. So like the social media or another things, use this type of data structure to store the information of the person and whose are the friends of the others. So next one is time series. Is also a different type. Alternative way to store time series database. So this is very application specific. Yeah, so this is the very specific to particular for any particular problem. Store some metric for or value as function of time, used for log analysis, performance analysis. Yeah, so this is basically used for the analysis purpose. So what time frame we are getting the data. So this is basically for a specific purpose. So going in detail. So next one is the NoSQL. Okay, so it started out of alternative to SQL. So that means, but SQL is just a query language, can be adapted for any kind of query, including from a document store for or graph, not only SQL. So that means so which we have learned the SQL thing. So we have the structured database, and then we are performing a specific query for that. So here we are storing the data in the different format, but we are also providing a same set of query, similar type of query like the SQL, but which are not the specific. We can also use the some extra or any other things with, so like the SQL, same like the SQL, but not exact the SQL. So additional query pattern for other types of data stores. So we can also perform some different types of operations for the NoSQL things. So here a word on acid. So this acid is basically a property of core principle of the database. So this stand for the atomic, consistent, isolated, durable. So yeah, here atomic is so this acid property is basically used for the transaction in our database. So for example, if we want to perform any set of operation with the database, so that is called the transaction. And for transaction, this acid property should be required. So acid atomic means if we are performing any transaction, so our transaction should be performed completely, otherwise it should be avoid completely. Okay, so for example, if we are transferring a amount from A to B, so for example we are transferring 100 rupees amount from A to B. So that means this is a collection of some operations. So we will reduce the amount 100 from the A, and then we will add the amount 100 to the B. So that means this is a collection of two operations. So that both two operations should be performed completely, or it should not any. So either the transaction should not be complete, it any part of the transaction should not be complete. So for example, this is not should be executed. So for example, the first operation is done, but second operation is not done. So this should not be the case in the transaction. This atomic properties say that our transaction should be completely performed, otherwise so 1 and 0 combination, we can say that should be either complete or not. So second consistent properties represent that for if we are using any database, so if any information is stored in the two place and we are fetching some information from our database, so for the same value, same parameter, we should get the same value. That means uh, two more than, so we can say that, for example, consistency. Okay, so our data should be consistent. That means more than two information should not be retrieved for any one particular parameter or one particular value variable. Okay, so if we are searching a amount, for example, if we are checking a amount of in our bank account, so same information should be retrieved by the, for example, we are performing two searching from the two place, so same information we should get. Okay, so that things is represented by the consistent. Isolated means if we are performing two transactions, uh, so both transactions should be performed independently and that should not be affect to the other transaction. Durable means our data should not be lost at any stage, so that means our data should be remain in the backup in anywhere, so that that should be secure if any failure comes, so that we can recover our data. So these all properties are important when we are performing any transaction operation. So most of the database try to fulfill this ACID property, but so many NoSQL database. Okay, so here we are talking about this NoSQL database, so that sacrifice some part of this ACID. So in the some part means that they just compromise with some consistent part. Okay, so example, eventual consistency instead of consistency for performance. Okay, so some place when the consistency is not much required, so that means if our data is not proper consistent and there is no loss, if for some small time this is not consistent, so there is no loss, then we can just compromise with this consistency. Otherwise, for some transactional purpose or for a banking purpose or very cost effective things where the if consistency is not occurred and we are getting much lost much loss for that, in that case this ACID property should be fulfilled by the database. Otherwise, some place we can uh, compromise with this consistency, that is called the eventual consistency for the performance. Why not ACID? So consistency hard to meet, especially when scaling. So distributing, yeah, scaling means for example, if our users are increasing and our application are growing, so that means our server is not able to handle all the load, so we can divide our load. That means we can make more than one server for our application, and we can divide the load into a distributed server. So in that case, so this consistency cannot be achieved. So we can use this eventual consistency, so this is easier to meet. So here one example is given: A located in India and B located in US, both add C as a friend on Facebook. So this is so for example, both add C as a friend, but this information is not visible to A for example, sometime it can be late for some time. So for example, if C is added to B and C is also friend for A, but A, this information is not visible to A. Okay, so it can be update after some time. So but this is not update at the instance of they are adding. So I think it is not creating any problem for that. So this type of, this type of case, we can use this eventual consistency. But for the final transaction, so that absolutely require acid property. In that case, we cannot compromise with this. A word on storage, a memory fast doesn't scale across machine. Okay, so that is other things. Okay, so the remaining things. Okay, so the remaining part is. Uh, so this is the, okay, I'm just talking about quickly. Scaling. Scaling means if you want to increase our okay, one second. Yeah, what happened, Chetan? Company and bot. Okay. Okay, so we're scaling. So scaling means how we can. So there are two parameters comes under this scaling things. So scaling, how we can add up, add new things in our system, and how we can increase our um, server. That things how we can increase our um, application availability for the maximum user. So that things is called the scalable thing. So replication and redundancy are two things which are come under this scaling thing. So redundancy means multiple, we can store our data at the as a multiple copy, and generally we use this redundancy for the backup things. So at any time if any failure comes, so we can recover our data from the backup. And so this is called the redundancy. And replication is basically used for the increase the performance. So performance means, so for example, if we, our servers have much load, so we can divide our server and we can replicate our data into a multiple servers. Okay, so we can distribute the load on the different servers, and that they can perform better. So in that case, we can divide our data into a multiple server. So that is mostly called the distributed server, and distributed database also comes in this side. So this, that operation are also performed by the in the efficient way. So usually in the context of performance may not be for purpose for backup. So replication is not about the backup purpose. That is come under the redundancy things. Multiple source of same data, less chance of server overload. Okay, so we just generally replicate our data into a multiple server, and they can handle the users request uh, in very good way. So live replication requires careful design. Okay, so here the live replication means if any update is happening on the one server, so that reflection should also be uh, that changes should also be reflected in the another server. So this is generally called the live application. So this require careful design. So how we are designing our application, how we are dividing our database, so that some algorithms are used for that. We are not going in much deep. So for this eventual type of consistent, we generally use the different type of property base. Okay, so BASE, base versus acid. So base stand for basically available, soft state, eventual consistent. So this is the different this property is basically used for the different type of database, no SQL type of database. Eventual consistency instead of consistency. So replicas can take time to reach consistent state. Okay, so if we are dividing our database into a distributed database, so definitely this consistent state is not possible quickly. So it takes some time. So latency will be high to come in the consistent state. So stress on the high availability of data. So there are some advantage and disadvantage for every things. Replication of traditional DBMS. So are DBMS replication possible? Usually server cluster in same data center, load balancing, that is also called server cluster. Application harder. Okay, so geographical distribution replication harder, latency constraint. Yeah. So if you are dividing a server geographically, so that is hard to maintain the proper consistency. Otherwise, at the same place, for example, if we are using a any cloud-based server, so that they can provide this replication things on the same place. So scale up and scale out. Scale up is basic approach if we want to increase the features of our machines. So larger machine, more RAM, faster network processor. This thing that is called the scale up, and scale out means we are just increase the servers. So multiple servers, harder to enforce consistency. Yeah, so we are increasing the different number of servers. That is called the scale out. So there are some disadvantages for the harder to enforce in consistency. Better suited for NoSQL, non-ACID type of database, better suited for cloud model, and auto scale up. Yeah. Application specific. Yeah. So we can also decide our database on the basis of application, financial transaction if we want to perform, so that this consistency is more important. So that in that case we can select any acid based DB. Otherwise, where consistency is not much important, we can choose the different type of database. And the last topic is the security. So security is also important when we are using a database. So here one example is given. So if we are using a SQL in, okay, so for application, so if you know about this non-AVC application, okay, so non-MVC structure to develop application. So generally we use the direct SQL query for in the backend programming. But in MVC, generally we use the ORM thing. So ORM just take care about all these things for this security. But when we use the non-MVC approach, so we direct use this SQL query, and this is dangerous sometimes. So how it can be create a problem. So for example, if here one form is given, and you can see that we are just collecting a username and password usually from the form. Okay, and in the backend side we are just performing this statement. Okay, so we are just collecting the name from the form element, and then when we are collecting the password. Yeah, this is wrong. Okay, this is password. So, and we are just passing these variable in our query here and here. So what happened if someone is provided the data in a different format, so like this. So if we are providing this ABCD here and the another value for A, so okay, so if we are providing simple value, then it will be passed like this ABCD and then password PAS, then it will be passed here, and then our query will be executed. But what happens if someone is providing the data in that way? Yeah, this type of way. Okay, so this is a text box and you can provide this type of data. Okay, so if anyone is providing this type of data, so what our query will look like? So you can see that, so this value will be passed here equal to in that way, and then here. Okay, so actually we are passing this value. So name equal to or or you can look at this. So I think complete query is not given. Yeah. Okay. So for example, this type of query we are passing that empty equal to empty. So yeah, it become, so here one something is missing. So empty equal to empty, right? Okay, and name equal to empty. So this type of thing. Okay, same things here. If this one and or equal to this one, so that value will come in that way, and so it will create a problem for that. So that means here or condition is given, so this side will be true for that, so this part will become true. Okay, same things for the password. This, if this condition is not satisfied, then this condition will become true. So your query will look like this: simply select star from user, and then there is no condition. Okay, so that means it will return all the users details, all the data of all users. So in that way, any hacker or anyone can get the important information from your database, and they can use. Okay, so same things. So this things is called the SQL injection. So that means we are just passing a string which are creating a different type of SQL query. Okay, so same things we can achieve. So for example, if we will pass input in that way, like in that way. Okay, so this is the input we are providing from the form, and this part is coming here and assigning like in that way. Okay, so this semicolon is representing this one query is completed here, and after that we are performing a second query. So this will be performed first, and this is not satisfied or satisfied, it may be satisfied, but second, when the second query will run, so that means drop table users, so that means all data will be removed from the users tables. So this type of SQL injection can create a problem when we are using a direct SQL query. Okay, so this type of security we should uh, keep in mind when we are using SQL. So how we can improve this? So we should validate all the values which we are taking from the form. So parameter for from HTML taken without validation, so that it can create a problem. Otherwise, in the uh, some parameterized query are available to just break this SQL injection condition. So this validation is required, or so we can check the data which we are getting from the form. So if any special type of characters are coming in the data, so then we can remove this. So this type of validation we can apply if we are using the direct SQL query. So this is the important things you should keep in mind before using the SQL related to security. SQL injection, buffer overflow, input overflow. If we are giving lots of data in as input, in that case, how will server behave like that? So length of the input is very large. So how we can handle this? So these type of some things we should keep in mind when we are developing a application. So this is handled by the application developer. So anything which you are developing, so that you are just putting this SQL query in your code. So just keep in mind before using this server level issue and possible outcome. So all, so what is the possible outcome? Loss, you can lose the data, exposure of data, manipulation of data, change can be happen. Okay, so as using this SQL injection and anything things, so this type of loss you can get from the SQL injection. And other things are, this is the protocols where we are using the S thing. So we are using S secure protocol. So it create a secure communication between client and server. So this is the some internal things that is handled by the server and your operating systems. So this is also important. Okay, this is the summary. Okay, so now we just quickly go through the activity question. Yeah, which of the following statement are true about the SQL? So SQL stand for incorrect. SQL is used for the query unstructured database. This is also incorrect. SQL is only used for querying spreadsheets, CSV file, etc. Okay, so this is also not correct. And last statement, SQL database is a collection of tables that store the specific set of structured data. So this is correct. Okay. Which of the following is true about the relational database? Okay, so in relational database, that means our data is stored in the tabular form. So document option is not correct. Key value is not correct. Okay, so which of the following is a not? Okay, not a type of. Okay, so document, key value, graph, time series. So all options are correct. Okay, so all are the different alternative way to store the data. Which of the following is an example of document database? So okay, so for document we have just checked that this MongoDB is generally used on the document database. Which of the following statement is true about the document database? So MongoDB is an example of database. Okay, this is correct. The document database is used mainly for handling large value of structured data. So this is not correct. Okay. And document database is designed to store the query data as JSON like documents. Okay, this is correct. And document database are the type of relation. So first and third option are correct, but second and fourth is incorrect. Which of the following are correct with respect to the storing data in graph? Okay. So data on social network can be stored with the help of graph. Okay. Yeah, this is looking correct. Storing data in graph involve different degree like number of outgoing edge. Okay, this is also correct. Data is stored as a key value. This is not correct. And in graph, path finding is more important than just searching the data. Okay, so third one is also correct. Fourth one is also correct. Okay. Yeah, so in graph storing, and then only the third one is not correct. Next activity, which of the following statements are correct? Redundancy refers to the duplication of data at several places in the databases. Okay, refers to the duplication of data. No, this is not correct. Redundancy is not used for the purpose of backup. Okay, this is also not correct because we can generally use for the backup. Data redundancy decreases the cost of storing and retrieving data. Refer to the duplication of data several. Okay. So first statement is correct. Okay, so generally we store the duplicate copy of the data at the several place in the database. Okay. Which of the following option refers to having multiple copy of the same data at multiple place with the two operators? Okay, which of the following option refers to having multiple copies of the same data at multiple place with the two of the server load? Okay, so for reduce the server load, generally we use the replication. So second option is correct. Which of the following are true? So redundancy is often used to connection with backup. Okay, replication is often used to connection with backup. No. First one is okay. Replication result to reduce server load. Yeah, correct. And redundancy result of reduce server load. So first and third is correct. Which of the following statement is correct? So yeah, stand for is not correct. SQL depends database support base property. No. SQL support ACID property. ACID is acronym by atomicity, consistency, isolation, durability. Yeah, this is correct. So first and third is correct for that. And this is the last one. Which of the following statement is correct? Okay, so SRM has more latency than DRM. More latency. No, it is not correct. DRM has more throughput. Okay, so just quickly check the answer for that. So, yeah. So here the DRM has more throughput than SSD. Yes, it is okay. And SMA SRAM is sorry, SRAM is more cost efficient with SSD. Cost efficient okay than SSD. No, this is not correct because SRAM is much closer to the processor and its cost high, it have higher cost. So among SRM, DRM, STD are most cost efficient. Yeah, STD is the lower cost. The lower. So first, second, and third is correct. Which of the following statement is true about the cold storage? So cold storage are designed to store high amount. Okay, this is correct. Data retrieval is very fast. Okay, so from cold storage, latency is high. So this is not correct. Cold storage offer high durability of storage data. Yeah, this one is correct. Owing to its storage capacity, cold storage are costly. No, so cold storage are the not the costly. So this is memory based. High latency of retrieval from Amazon Glacier takes up to. So these things you can just find out the correct answer from the Google app. Which of the statement is correct about the HTTPS? Okay, so HTTPS is the first one. Is HTTPS provides secure socket which stabilize secure communication between client and server. Okay, this one is okay. It stand for Hypertext Transfer Protocol, but here S meaning is not given. This is not correct. HTTPS is more advanced and secure version of HTTP. Yeah, this is correct. HTTPS is one of who perform validation and safety checks. Okay, so validation is not checked, but it provide the a secure communication between client and server. Okay, so here the only first and third is correct. So these all are activity question. So same things you can solve the practice assignment question. So if you have any doubt, I have some issue in my lab assignment series. Chetan, so for lab assignment, I think you can post on the discourse because I am not looking these lab assignment things. So you can post on the discourse and just tag to the others, and others is also not in the meeting. Yeah. Otherwise, in the next session, maybe others will join. So you can ask. Okay. So I think we can wind up the session. If you have any problem, you can post on the discourse. Okay, Chet.
Thank you, sir.
Okay, Prerna. Thanks. Yeah.